Or, oh, sorry.
This subject, he's Richard Yan from Enterprise DB. This topic is for security for Postgre, I think. Uh, let's welcome.
Thank you. Hi, thanks for joining this talk. My name is Richard. I'm a software engineer for Enterprise DB. I'm going to give a talk on how to use Postgres. This is a kind of a beginner level talk geared towards people who are not Postgres DBAs, but people who are developers or engineers or data scientists who might need to use the database because the DBA is not around or maybe the organization doesn't have a DBA. So yeah. Just a little bit about myself. I've been using Postgres since 2002, and before being a DBA, I was a Perl developer, and then joined EDB as a support engineer. So EDB provides support services and other services to help you manage your data and also to migrate to Postgres if you wish. I'm currently working with Golang and Python to do some internal tools for our company. And I'm here to, I'm really happy to give this talk for you. As many of you may know, Postgres is a very powerful database. There's a lot of things that you can do with it. And there's, to go over all these topics, it would take many, many days, maybe even many weeks. So what I want to focus on is how to work with the database safely without a DBA around. So these are some of the topics that would be very, hopefully we can cover these today. I want to be able to talk about just the basics of how to connect to the database, how to stop it, start it, to find out what's going on, to be able to manage whatever situation is going on, and also to be able to know where the data is located so that you can back it up and archive it in case you need to. So I don't have a lot of time, so I'm going to go through it pretty quickly. So please excuse me. If you have any questions at the end, I'll be around. I have another talk after this, so I'll be here for the whole day. So I'll be happy to answer any questions you might have. So the first thing, the most important part of working with the database is actually connecting with it. So if you're not able to connect to it and to start and stop it, it might be some trouble to use it. So Postgres generally runs on Linux, but it can also run on Windows and other operating systems. The most flexible way to use it is by using SSH and having the command line to be able to connect. Now, I know that many people might use cloud-based services like RDS or Azure. So from those, you need to be able to start and stop it from the console. Now, why do we need to know how to start and stop it? Is because if something is bad or something bad is going on, we need to be able to stop it before any worse things happen, any kind of data loss. And we need to be able to start it because maybe the database crashed. So we need to be able to find out how to start it up. Now, before we actually start it up, we actually do need to perform some sanity checks. First, you need to know how much disk space is left. If the disk is full, then it will not start up. And if the disk is full, then we will need to know where to copy the data to. Hopefully, there will be enough data in a partition that you can copy files to in order to open up space. Also, it would be important to know where the database logs are so that you can find out why a database crashed or why it was shut down. Now, I'm going to go over this part pretty quickly. As many of you might know how to use Linux. we will generally use systemctl to start the database, and depending on some of the operating systems, you may need to have the version number to provide to it. If systemctl is not working, or if you need to use other ways to start the database, pgctl is the main way to start it and stop it. This command is actually what the systemctl uses. So if you want to skip the systemctl part, you can use pgctl. Now, the important part about using pgctl is that you need to know where the data actually is. So it would be important to work with someone in support, or work with your DBA or someone who might know, whoever set up the database, where the data is. So have that stored somewhere on your notepad, or in some kind of document, so that you know where the data is. Okay. Now, there's different ways to stop it. You can use it without any flags. You can use it with the MF flag, and then you can use the MI flag. Now, stopping it without any flags, you will need to wait for all the connections to exit and end before it will stop. So that's not that's going to take a very long time. Now, the MF flag is a fast mode, and the fast mode it will stop the existing connections. So queries will be ended, and then it will stop. So it'll stop a lot faster. Now, sometimes the MF might not work, so you do MI, which is immediate, and that will actually it will actually crash the database. So you don't want to use that too much, because when you crash the database, when you start it up again, it has to do a lot of scans to be able to start up, and that will take a long time, depending on how much how large your database is. Okay, so that's stopping and starting. To actually connect to the database, you're gonna need the host name and port, username and password to be able to connect. Now, sometimes you can get that from your application, or like a keychain or something like that. And then you can use PSQL to pass these parameters in. Now, if you don't want to use PSQL, or you cannot get a terminal, things like pgadmin and dbeaver are good graphical user interface database connecting applications that you can use. So I know there's a lot of tutorials on there on the internet that will allow you to do this, so I'm not going to go into too much more detail about this. Now, once you've connected to the database, you can actually look at things like what tables are there, right? And so you can see here I do a \D, and then you see these two views. Now, the thing is, many of our customers that in the past they have put all their database information into another namespace or schema. So if your table doesn't show up here, what you want to use is the \dn to see what other schemas there are. And then from there, you can actually see here, there's a my schema and there's a result schema. And then from there, I can actually do changing the search path to include my schema and results. And then when I do \D, it will show all the tables. Okay. So from there, you can so you may want to read data out of those tables, but what some people are more interested in is what is going on in the database in that immediate instant. So what you can do is you can use a query called select star from pgstat_activity. Pgstat_activity is a view. It's like it is kind of like a table, but it shows you what's going on in the database on that very instant. For people using RDS or managed databases, or if you don't have super user access, you may not be able to see everything available, but at least you will be able to see how many processes are running, some of the process IDs and things like that. So that might still be useful even if you don't have super user access. Now, what I would recommend is try to figure out who in your organization has super user access, so that way you can actually work with that person to find out what is going on in the database at that time. Another good way to find out what's going on into the database is by using the Postgres logs. From the POSQL prompt or sending a query show log directory, it will show you the directory where all the logs are stored. And from there, you can actually find out what queries have been run, what kind of errors are happening, and from there you can figure out what kind of situations you might need to resolve. Okay. RDS logs, you would actually view the logs in CloudWatch or some other logging facility in a managed database. Now, super users, they can cancel or query or terminate a session with these two commands, pg cancel backend and pg terminate backend. Now, pg cancel backend will actually just cancel the query, and then the whatever program was opening the session will be able to continue to run other queries. However, if you run pg terminate backend, it actually ends that session. So whoever is connected to it, whatever application is connected to the database, that application or that user will be cut off from the database, and they will have to log back in again. Again, these are limited to super user users, and then in your own. So if you're the owner of the PID, then you can still run these. Okay, so let's say I run this and I see that this is the output of PG stat activity. It's a little bit tricky to read sometimes because it's a really wide table with many columns. Sometimes what I would do is I will use \x, which turns on the expanded display. So it converts all the columns into rows, and then that way you see something a little more neat. So from here you can see that the right side there's like an auto vacuum process running, and then on the left side, on the right side, you can see that my query, what I was running, which was pg stat activity limit 2 offset 1. So you can see very useful. You can see what query is being run. If it's taking a long time, you can see how long it's been since that query started. So if it's a very slow query, you may need to cancel it, you may need to terminate it. Now, again, since this is a talk for people who haven't been using Postgres much, you might be wondering what is auto vacuum and what is vacuuming and why is that important? It is a very important part of Postgres because it is what keeps it running smoothly. Now, vacuuming is something that keeps performance by preventing bloat. Now, this is because in Postgres, when a row is updated or deleted, it's not actually removed from the disk. It's actually flagged as invisible. So we can't see this. We can't see those rows anymore. What vacuum does is it takes those invisible rows and it says, "Hey, you can reuse these again." So at a certain time, when you vacuum it, when other inserts or other updates come in, they actually reuse those rows that are invisible. So vacuuming is that process of identifying which rows are reusable, and that way you don't keep adding more rows and keeping the invisible ones, and then that way you get bloat and the database slows down. So vacuum is actually very important to let it keep running and actually run pretty often. Okay. Now, sometimes as an admin, or if you have super user access, if the vacuum is taking too long and it's blocking other queries or making other queries slow down, you may need to use pg terminate backend to stop the auto vacuum. However, if you do that, when the vacuum comes back again, it will vacuum that table. The auto vacuum will keep vacuuming that table until it's done. So you may need to have to just manually run it. By doing that, if you want to do that, you need to set vacuum cost delay to 0, so that way it doesn't keep taking time to. Sometimes it will pause to let other processes access tables, and by setting vacuum cost delay temporarily to 0, it actually lets it run as quickly as possible to finish the vacuum. Okay, so other performance-related ideas I want to share with you. So many of you who are developers or data scientists, when you run a query, it may take a long time, and you might wonder if it can be made faster. Now, the way to determine that is by using something called explain and explain analyze. I have another talk on this that takes about 45 minutes to an hour, so I can't go into all that detail here since I only have 30 minutes. But basically what that does is you can actually, I'll give you an example real quick, but you can use explain and explain analyze from the command line or from your query editor. Or you can use something called auto-explain, which is a extension that you can have installed. I highly recommend that you install it, work with your DBA or another coworker who has super user access. Auto-explain is very, very helpful, especially if you're using an ORM, because ORMs do a lot of automatic joins and automatic query generation, and sometimes it's not optimal. So, give you a quick example of from just a regular explain and explain analyze. So I set up pgbench, which is a very simple built-in benchmarking tool. And here I'm running explain select star from pgbench accounts, join with pgbench branches on the branch ID where the AID is less than 100,000. Now you can see here, I'm going to return 99,999 rows, and then it does 2 sequential scans. Now this is somewhat useful to know what scans are going to be used, and what this does is it just tells you the plan. The query planner shows you the plan that it's going to use. It doesn't actually run the query, so you actually get this right away. You don't have to wait for the query to finish. So this is useful to predict what kind of activity is going to happen. If you want to actually run the query and find out what happened, you use explain analyze on that same query. Now this time you see the additional things in the yellow. Now you can see that the sequential scan took, first one said 0.026 seconds, and then the 0.026 milliseconds, and then the second scan took 25 milliseconds. And the overall time, it took 61 milliseconds. So you can see that with running the query, you can see the actual performance. Now, this might be the best you can do, or it might not be the best you can do. So you have to play around with it and figure out what ways you can improve the query. Sometimes adding an index might improve it. Instead of using sequential scans, you'll use an index scan, and that would take some time and research to do. Okay. I'm going to let's see. So, all right. I'm going to talk a little bit about the configuration. So if you are unfamiliar with Postgres, all the configuration parameters are in PostgreSQL.com. This usually lives in the PG data folder. The other way to control the configuration, you can actually use alter system. Now, alter system, it will actually make a file called PostgreSQLauto.com, and from there it will actually so it won't actually touch PostgreSQL.com and edit the configuration there. It has its own separate configuration. So if you need to find out what the settings are and what needs to be changed or whatnot, these two files are good places to look. Other ways to find out how the database is currently configured, you can use show all. Now, show all shows you the current configuration. So some people actually may make changes without committing them to PostgreSQL.conf or PostgreSQLauto.conf. So show all shows you the current configuration, even if it's uncommitted. Other ways to view. So if you look at the PG settings table, this will actually show you some of the parameters that you can change. Because some parameters require a restart of the database, that actually cuts off connections. It actually makes your application unavailable. So we don't want to restart the database with new configuration unless there's a scheduled downtime. But some of those things you can change without actually restarting the database. Now, to figure out which settings those are, you can use this first query, select name setting from PG settings, where context is SIG-hub or user. SIG-hub is you can reload the config without restarting. User is only this current session. It will be valid. So for those user level configuration parameters, you can just set parameter to value. So I say like set search path to results, set search path to whatever schema I need. If you want to make a more committed change, you say alter system set, and then that value will get added into PostgreSQL auto.conf. So to actually commit the changes, you actually select PG reload conf, and then that will actually commit those changes, and then next time you log into the database with PSQL or PG admin, you'll use those exact values. You can also make the changes from the operating system as well. Now, some of the configuration parameters that are non-disruptive are these ones, and I would like to make you aware of them. So, oh man, okay, so search path, again, is the way to control which namespaces or schemas are visible by default. Workmem is important for improving some of the query scans and query performance, but you have to be careful not to commit those to commit too much memory, or else you can actually crash the system. Now, these log parameters are also very useful. I won't be able to go into all of those, but the two I want to focus on are log line prefix. So the log is a text log, so every certain queries, certain activities will get logged into that text file. And having this prefix is very useful to actually figure out which database, which user, which application caused that to happen. So if you ever need to go back and figure out why something happened, why a delete happened, why a database crashed, having all this information available will actually be very useful. The second most important logging parameter, I think, is logmin duration statement. It actually helps you track how long a query took, and that way you can kind of figure out where your performance bottlenecks are. Okay. So I want to make sure, since not everyone is used to Postgres, database logs are not wall logs. Okay, and I want to go into that really quickly, because that is a very important part of Postgres. We've actually had many customers, unfortunately, deleting their wall logs or losing their wall logs, and actually losing data as a result. So WAL stands for write-ahead log, and what that is a journal that writes all the activity of the database into these WAL files. Now, what this does is it provides a way of disaster recovery. So when you actually perform a query like update, delete, or insert, that actually gets put into memory. And then at certain times, it actually gets pushed into a wall log. And at certain checkpoints, we can be sure that those information are saved. So if the database crashed, it will actually have a place to start without actually losing the data. So these files, they live in PG wall under the PG data folder. Sometimes people will put it into a separate partition, so it will be sometimes on a different disk. So you need to be careful to know where those files are. We do not want to delete those files. Once you delete those files, you will lose data that was that was updated or inserted. Okay. Now, so just giving you a quick screenshot to see what it looks like. So there's a folder called pgwall under the PG data folder. So the top yellow line is a PG data folder. If you look at it, there's a pgwall folder. Inside the pgwall folder is a bunch of files that has a bunch of zeros, numbers, and letters, and those are the wall files. So these are the files that we don't want to touch. One good way to know whether they're wall files or not, another way is to see the size. The size is always 16 megabytes. These are 16 megabyte files. Some organizations will use larger or smaller wall files, but that's very rare. So if you see a 16 megabyte file, best to not touch it and not to do anything with it, unless someone who has more experience with Postgres can tell you what to do with it. Okay. Okay. So I want to talk about backups. So if you have access to Postgres, you want to be able to back up that data before you lose it. So there's two ways to back up. There's a way called pgdump. Pgdump will dump a plain text file of a bunch of SQL commands, and that will be able to, you can compress it, you can put it somewhere and archive it. This is very useful to be able to avoid copying any corruption. This is because so there's three types of corruption. There's corruption on disk, so the disk, the magnets or the switches got messed up, and that file on the disk is no longer readable, so that's a disk corruption. A second type is maybe there's a PostgreSQL bug that changed the data and inadvertently deleted or hid some data. So that would be another type of corruption. And then another third type of corruption is corruption that was caused by a person or a stray update command. Right? So like let's say somebody updated without a where clause. They updated the entire table. Right, or they deleted without a where clause, or they deleted without a begin and rollback commit. So those are the three types of corruption. pgdump will help you avoid the first two. So corruption on disk and corruption by a PostgreSQL bug. The second method of backing up is PG-based backup. Now this actually copies the entire PG data folder. So that will also copy any bad files, any corrupted files too. But the nice thing about PG-based backup is that it is very fast. It just takes a snapshot of the disk, and you can actually replay it or load it up somewhere else. So all the indexes, foreign key constraints, everything's all already there. So you don't have to wait to recreate those. However, you also do need to have the replication privilege. So someone with super user access will need to help you get that set up. Okay. All right. I'm going to wrap up with things that you should not do. So just kind of like a summary. So don't kill 9 on any process, because what that will do is it will crash the entire database, and it will enter recovery mode. So when you start it up again, it has to scan the entire PG data folder, and that could take a very long time. When you are working with idle transactions, when you were working with queries, always commit and roll back the transaction. Sometimes people write programs and they forget to add a commit or rollback, and that actually leaves the transaction open, and it actually blocks other users. So we need to be careful to write your code and include the commit and rollback. And if you aren't a DBA, or if you don't feel comfortable, don't drop anything. You can always rename things. So rename a column, rename a table, and then when someone who can help you, they can help you remove those properly. Okay. Okay. So that wraps up my talk. If you want any further help, I highly recommend reading the documents. The PostgreSQL documentation is very, very good. I use it all the time, especially when I forget about things. And then if you need support, you can always send a message to EDB support. If your company would like to have a support contract with us, we would be happy to arrange that. The Slack, mailing list, IRC, they're all very, very good. People are always on there and very, very polite and very willing to help. So don't feel afraid to ask there. All of these links are at the bottom in the link tree, Postgres help. So yeah, so that wraps up my talk. Thank you very much for coming, and I hope you enjoy this one, and please join me for the next talk on foreign data wrappers as well.
Linux distribution that you recommended for running Postgres, and why?
I use both. So I use both Red Hat and Ubuntu. It really depends on your organization. So a lot of the companies that we work with, they use Red Hat, but a lot of the open source groups, the smaller organizations, they'll use Ubuntu because it's free. So I think Red Hat is more of an enterprise, like companies, they buy the whole support package, so it costs more. So if you're worried about costs, then I would recommend just using Ubuntu. Okay. Both of them are very good. They actually, they perform the same. I think it matters more about the hardware. The Linux distribution doesn't matter too much.
Do you recommend to use Windows for Postgres?
So Windows is good. It is harder to work with, mostly because I think mostly because of the way that Postgres is built. I think the native development is in Linux, and we have a separate team of people who customize it for Windows. So it does work well. It's just that when you need support, it's harder to get support. EDB does have a support team that will to support Windows. But yeah, it is harder to work with. Sorry.
Any question? Okay, thank you.
Okay.